So it's almost Valentine's Day again, and that's why I decided to go with Paris and wear pink, just for all you single ladies out there. And some of you guys. Yep, it's that time of the year again, and for all of us, a year has passed. But according to science, time doesn't pass for everyone at the same rate, depending on the situation that they are in. So allegedly, the closer you are to an object with mass, the more time slows down for you. That's why time stops when me and Eeyore are together. Right, Eeyore? He's single, by the way. So if we had to think about the age of the Earth, and the fact that the Earth is billions of years old, and the gravitational forces are much greater at the core of the Earth than they are at the surface of the Earth, then that means that the Earth is 2.5 years younger at the core than what it is at the surface. And according to Einstein's theory of special relativity, the faster you travel, the more time slows down as well. Time pretty much comes to a complete standstill at the speed of light. So for us, a photon traveling from the Sun to Earth takes 8 minutes and 20 seconds. But for that same photon of light, it is instantaneous, because time comes to a complete standstill as it is traveling towards us. And then the cherry on the cake is the space-time continuum. So apparently time and space are like this woven fabric that runs through the entire universe. And then massive objects like the Earth bend that fabric, which creates gravity. Man, science has come up with a load of crap over the past few years. Now I know what you're thinking, but I've got pretty much the same hairstyle as Einstein, so I think I'm allowed to criticize the guy. And I know his theories have been proven countless times already. I know about muons, and I know they have to make adjustments on satellites to account for time dilation. But I'd still like to share my understanding of time with you guys. Look, I'm not a particle physicist, and my channel's not about me having all the answers and telling you guys what all the answers are. So here's a rundown on my understanding of time. Let's get something out of the way first. Is time an illusion? Well, obviously not. This video took a hell of a lot of time to make. Correct me if I'm wrong, but I think when people say that they think time is an illusion, they're talking about the measurement, and they will go on to say that time is a man-made construct. Now there is some truth in that, but let's apply the same logic to distance. So this over here is 1 meter. It's about the size of that TV. And that there is 1 centimeter. So those are both measurements of distance. But in actual fact, a centimeter doesn't actually exist. And a meter doesn't actually exist. We just decide as human beings what to define that as. But does that mean that the distance between where I am and where you are right now is an illusion? So yeah, no, it's obviously not. It's only our measurement of that distance which is man-made. But the distance between where I am right now and where you are is very real, and that isn't an illusion. And the same thing applies to time. Seconds aren't real, minutes aren't real, hours aren't real. Our measurement of time isn't real, but time itself is an illusion. It is actually still real. Days, on the other hand, are kind of an illusion. They only exist on Earth. As soon as you go out into space, it's all the same day. I'll get into debunking other theories about time a bit later on in the video. But for now, I just want you guys to see time like I do. So YouTube has this nice little progress bar at the bottom over here. If you look at the bottom left, you'll see a time indicator showing how far along you are in this video. Now that perfectly demonstrates what time actually is and what the constrictions are of time. We are constantly moving from the past, which is that red line before the dot, into the future, which is the grey line in front of the dot. The exception being that the past doesn't exist anymore and the future doesn't exist yet. All you have is that dot, these constant moments of now, now, now. A lot of people believe in an existence outside of time or beyond time. But if we think about time in this way and use a video as an analogy, what is an existence beyond time or without time? As you can see, an existence without time isn't possible because there would be no movement. So now let's take that way of thinking about time and go back to Einstein's theories. In his theory of special relativity, he says the faster an object moves, the more time slows down for that object. So over here I've got our object, and I'm going to move it around really quickly. Now, how much did time change for this object versus me in that progress bar of yours? Now obviously this isn't a very good experiment or demonstration, but I hope it makes you realize how absurd the idea actually is. that me doing anything within this frame over here has an effect on that timeline down there. They are two completely separate things. There's absolutely nothing I can do within this space over here, within this frame over here, that could have any influence on that timeline over there. The idea is absolutely just ridiculous. And then there's his theory about general relativity. Now I'm sure you've noticed that I've left the moon and Earth on the screen since the beginning of the video, and that they both have separate clocks running at different speeds. Now the reason for that is because the gravitational forces on the Earth are a lot stronger than what they are on the moon. And according to Einstein's theory of general relativity, if you have a greater gravitational force, time moves slower. Ergo, time moves slower on the Earth than what it does on the moon. And the moon and the Earth have been around for billions of years, which means their clocks have been moving at different speeds for billions of years. Now I don't know the numbers or the maths on how many years that is exactly, but I don't think that is needed to make the point here. If time dilation were real, it would literally mean that parts of the universe would be going more and more and more into the past, and other parts of the universe would be going more and more into the future. Because time is moving slower, for example, around the black hole versus at the outskirts of the Milky Way. Now that would literally mean that when Neil Armstrong landed on the moon and looked back at the Earth, he was probably looking back at us right now in 2021, into the future. And when we look up at the moon, we are looking into the past, which means if we take a telescope and aim it at the moon, we should be seeing Neil Armstrong there right now. Because the moon would literally be in the past, and the Earth would literally be in the future. Now, does that not clearly debunk Einstein's theories, no matter what proof scientists claim to have found? These great minds and great physicists and great scientists are just human beings like all the rest of us. With any experiment, I think it's always possible for misconceptions to creep in, and for the person doing the experiments to draw the wrong conclusions. Okay, so I had a lot more planned for this video, but it's Thursday and I need to release this video, and I'm not spending a shitload more time on it. Maybe at a later stage I'll make another video where I go more into detail about all of this stuff. But there's one last thing that I wanted to show you guys. So I'm sure all of you have seen this demonstration before. Space-time continuum, right? There's the sun. There's the planets. And now, the sun bending the space-time continuum causes the planets to gravitate towards the sun. Right? Normally there's a little bit more. It's on the bed, so it's not going down nicely. So this is a known explanation for gravity. The thing about this demonstration is that it actually uses gravity to explain gravity. Because the only reason why these objects would roll down to the object in the middle is because the object in the middle is lower down than these objects. But that's not lower down in the space-time continuum, that's just lower down in space where this demonstration is being done. So this demonstration doesn't actually show why a bent space-time continuum would make objects gravitate towards each other. Anyways, that's all I have time for in this video. Have a killer week.